Solution stoichiometry always follows the same 4 steps. First of all, it is stoichiometry. And so in any stoichiometry, the first thing we need is to write a balanced chemical reaction. So in this reaction, I have 62 milliliters of 0.45 molar sodium chloride reacting with 65 milliliters of 0.3 molar lead-2 nitrate. So sodium chloride plus lead-2 nitrate. This is a double replacement reaction, so the cations switch places. So my products are sodium nitrate and lead-2 chloride. You need to balance this reaction. So we would need a 2 there and a 2 there. And then additionally, you also need the states of all of your reactants and products. You would define the states of the reactants and products based on the solubility rules. Soluble means that it's aqueous. So those two are aqueous. Sodium nitrate is soluble, so it's aqueous. Insoluble means that it's solid. So lead chloride is insoluble, so that is my solid. That is my precipitate. That is what I'm going to determine the mass of. The second thing you always need to do is you need to find the mole of each reactant. To do that, you are going to rearrange the molarity formula. Mole is just molarity times liters. So when I take 0.062 liters times 0.45 molar, I get 0.0279 mole of sodium chloride, and I get 0.0195 mole of lead nitrate when I take the concentration of the lead nitrate times the 0.065 liters of lead nitrate, sorry. Third thing you need to do is you need to identify your limiting reactant, and you can do that however you did it before, whichever method you preferred. Ideally, at this point, you would understand enough about mole ratios to be able to look at this and say, based on my balanced reaction for every 1 lead nitrate, I need 2 sodium chlorides. So I need twice as much sodium chloride as lead nitrate. When I look at my amounts, I have 0.0195 mole lead nitrate, 0.0279 mole sodium chloride. 0.0279 is not twice as much as 0.0195. So that means that this is my limiting. If you need to work it out, write it out, that's totally fine. It just saves time if you're able to look at it and identify it. Step 4 would be to do stoichiometry to your precipitate, because that's always what you'll be solving for, is the mass of your precipitate. So of course, when you're doing stoichiometry, or whenever you're finding product, I should say, you start with your limiting reactant, because that's what the limiting reactant limits. It limits the amount of product that can form. So 0.0279 mole sodium chloride, and then I can jump right into my mole to mole ratio. So 2 mole sodium chloride, 1 mole lead chloride, and then 1 mole lead chloride, 278.1 grams off the periodic table. And again, I'm going to the lead chloride because that's my solid product based on my solubility rules. That's my precipitate, and so that's what this question's asking for. And so when I get that answer, I'm going to use significant figures here. 3.9 grams lead-2 chloride. 2 significant figures because looking at everything that I was given, the fewest number of significant figures that I was given is 2. Another example, we're going to use the same 4 steps. So step 1, we're going to write a balanced reaction. So we have potassium carbonate reacting with calcium bromide. That is going to form calcium carbonate and potassium bromide. Balancing, I would need a 2 there. based on solubility rules, potassium carbonate's aqueous, calcium bromide's aqueous, calcium carbonate solid, potassium bromide's aqueous. Step 2, you're going to get the mole of your reactants. So potassium carbonate is 0.0995 mole, calcium bromide 0.08322 mole. And again, I did that using the molarity formula, rearranging it, concentration times liters. Step 3 is going to be to identify your limiting. Now this is a 1-to-1 ratio. So for every 1 potassium carbonate, I need 1 calcium bromide. So if I had 0.09955 mole potassium carbonate, I would need 0.09955 mole calcium bromide. I don't have that. So that makes calcium bromide the limiting. And then step 4 is just going to be the stoichiometry to your precipitate, your solid product. So mole calcium bromide, then our mole to mole step, and then go to grams calcium carbonate, which is 100.09. When I solve that, I get 8.3 grams calcium carbonate. Again, sig figs, I was given 3 there, 3 there, 2 there, 3 there. 2 is my fewest, so my answer goes to 2. You don't want to, when you're doing your mole amount, you don't want to round that to sig figs. Remember, you do not want to round to sig figs until the very end of your problem. Rounding too early can throw your answers off. So only round at the very end when you are giving me the mass of the precipitate.